Good morning, everyone. I will be talking to you today about rational decision making, especially about rational machines. This is a picture of a bridge in Sandton that collapsed. This bridge collapsed and killed 2 people and injured many. The question that I would like us to answer is, could we have prevented this? Is there a way that we can be able to predict whether buildings are going to collapse before they collapse so that we can be able to save lives? I have a question for you. Suppose South Africa's Minister of Finance, Mr. Tito Mboweni, wanted to decrease government spending. He has 2 options. Option number 1, reduce government workforce. Option number 2, consult a Sangoma from Dutuni who gives a concoction called Mdaka to drink, and this will reduce government spending. I am from Dutuni, so I know about Sangomas from Dutuni. Which option do you think he should take? Of course, it's option 1, because it uses relevant information to solve a problem. The use of relevant information to optimally achieve objectives is what we call rational decision making. Can we be able to use rational decision making in order to solve that problem that I talked about? The problem of preventing buildings and structures from collapsing, or of knowing before they collapse so that we can proactively prevent them from collapsing. To answer this question, I am reminded of my grandmother. I spent the last few days looking for the picture of my grandmother. I couldn't find any. Otherwise, I would have wanted to show you a picture of my grandmother. My grandmother was an organic engineer. She was my first engineering teacher. She used to make clay pots. And to make clay pots requires one to go and look for clay. I used to accompany her next to the river so that she can be able to collect clay. I know many of you are young. You might not know clay is found next to a river. You can't find it in dry places. So we'll go there, and then she will select the best spot where she's going to collect clay. When I was an engineering student, this is what they called material selection. And as engineering students, you are taught about softwares that help you collect the best material in order for you to meet your goal. After she has collected clay, she will bring it back, and then she will form it into a pot. As you can see, a pot is actually quite a complicated structure. It is round, it is hollow so that you can be able to put food inside. If it is too thick, if the walls are too thick, it will require much more wood in order to cook. If it is too thin, it is not going to last. So this is what is called an optimization problem. And you have sophisticated softwares that are able to assist you to optimize. My grandmother had no access to those optimization software, so she could not be able to use formal optimization techniques, but she could be able to make those choices from her own indigenous knowledge. After she has done that, she will take it to the sun so that she can be able to dry it. And when it is dry, she won't go and cook with it because it's going to break. She will take it into the oven and she will bake it. She will bake it so hot that it will be red. Then she will allow it to cool very, very slowly. She will not pour cold water into the pot because it's going to crack. She will allow it to cool slowly, and that process of cooling slowly is called annealing. there is a famous algorithm called simulated annealing that is used in artificial intelligence in order to be able to solve complex problems. My grandmother knew all the principles, but she did not know anything about annealing. In fact, there is a mathematical equation called the Boltzmann equation that describes the annealing process. It was discovered by an Austrian physicist called Ludwig Boltzmann. My grandmother did not know anything about Boltzmann, let alone his equation. Now, after that, she will do what is called structural integrity assessment. So what she will do, she will take each pot and she will knock it and she will listen to it. And based on the ring of the pot, she will know whether it is a good pot or a bad pot. So after she has done that, she will go and sell it. As she was growing old, I realized that my grandmother was throwing away good pots. The reason why she was throwing away good pots was because her hearing was deteriorating because of age. Now the question is, can we be able to take that process and take it into the technological era? Of course we can. So going back to the picture of the bridge, what you do, you install something called accelerometers. Accelerometers are devices that are designed in order to measure the movement of structures. You install the accelerometer on the structure, and then you excite it. And there are many ways in which you can excite it. You can just take a hammer and knock it. Take the measurement, and that measurement is called vibration data. So in a way, that vibration data is similar to the sound that my grandmother listened to. After you do that, you will take that vibration data into an artificial intelligence algorithm. Artificial intelligence is able to analyze complex data much more efficiently than a human being, certainly more than my grandmother. So after we do that, we can be able to establish whether that structure is in good condition or not. If it is in good condition, you can continue to use it. If it is in bad condition, then you will have to evacuate people and fix the structure. So these are the pots that my grandmother used to do. Now, this whole concept is rational. Now, if we were to compare the rationality of my grandmother and the rationality of the artificial intelligence machine, both of them are doing the same thing. They are assessing the structural integrity of a bridge or a port, but one is using the biological instruments such as ears and sound. Another one is using artificial intelligence and accelerometer. Which one is more rational? It turns out that artificial intelligent machines are more rational than a human being. Because artificial intelligence machines are more rational than human beings, they are now preferred as a means of production in industries than human beings are. Because they are more preferred than human beings, our factories are being automated, and jobs that used to be given to people are being given to machines, with all sorts of implications for society. In fact, because of this reason, we are reaching what is called the post-work era, where factories are going to be smaller and smaller, where you are going to see more machines in factories than human beings. So what is to be done in an era where machines have taken over the factories? What is to be done in the workforce? What sort of jobs are we supposed to have as human beings? It turns out that as we move forward, there are three things that are going to happen to the world of work. The first thing that is going to happen, some jobs are going to disappear. The idea of jobs disappearing is not a new issue. For those of us who are old, we will know that before, when you used to get into an elevator, there used to be a person employed called an elevator minder. The responsibility of such a person was basically to be able to direct the lift. Now, of course, that task is given to you, the user. You go there are numbers. If you are going to the 4th floor, you press the 4th floor. So some jobs are going to disappear. Some jobs are going to change. They're going to change because they will require you to work alongside a machine. And this obviously means we have to skill ourselves so that we are able to work with machines and increase productivity. Then some jobs are going to emerge. These are the jobs that we do not know about. In the 80s, there was no job called data analyst. Today, you have data analysts. So these jobs that are going to emerge, we don't know what they are going to be. Now, as educators, how do we educate our people so that they are going to be fit for jobs that do not exist today? And my solution is that our educational experience must be multidisciplinary. Those who are studying technological subjects must study human and social subjects also. Those who are studying human and social subjects must study technological subjects. This is what we call the convergence of humans and machines, which is the world we work in. In fact, there is a saying that says that one of the most effective techniques of punishing somebody is to separate them from their phones. The studies show that if you take away a telephone from an individual for a period longer than 3 hours, the activities of their brains start looking like the activities of the brains of a person who is trying to stop doing drugs. Let us not be afraid of machines. Let us use them in our production. Thank you very much.